Hello, pre-calculus friends. This is really for Christian only because we're going to do this in class unless you're stuck at home for some reason. So this is what we're doing Tuesday or Wednesday next week. These are word problems from section 1.3. And we did a little bit this the other day with the average rate problems. So that's easy. Remember, rate is like slope, and usually it's over time. Time is usually the bottom thing. And in this thing, if I read it, it's the population. So it's going to be population over time. So I always like to write that down so I know which things to put on top. Now it decreased from this to this, and I say, oh, decrease, that means the slope is going to be negative. So just make sure you're kind of keeping in touch with that. So to make it negative, you would have to take the 701,475 minus the 1,027,974 divided by your years. Normally you would write 2012 minus 1990 for the bottom, but they already told us that that was 22-year period, right? So I don't have to do that math because they already told me. And of course I didn't do this ahead of time, so now I'm typing it into my calculator. 701,475 minus 1,027,974. My calculator says a negative 3,264.99. And I'll divide that by 22. And so this is a negative 14,840. I'm going to round it to 1 because it's 0.8. So, and that's really people because it's the population per year. That's how many people left Detroit as an average every year. That's a lot, in my opinion, but what do I know? I don't even know if there are 14,000 people living in Allegheny County. Anyway, all right, so now let's do the next one. Same kind of thing. We're finding the rate of change. So we're going to put time on the bottom. There's not much room here. Put time on the bottom, and we're going to talk about revenue, right? So the money goes on the top for the revenue. So I have increased from 141 million, so it's an increase, so I know it's going to be positive, to 320 million. So you don't have to have all those zeros. You can just do 320 minus 141 over 212 minus 1998. So 320 minus 141 is 179. And 2012 minus 1998 is 14 years. So 179 divided by 14 is 12.8-ish, or 13 if you want to round to a whole. I don't really care. So like 13, I'm going to actually call it $12.8 million in 1 year. That's a lot of money. I don't even know how anybody can spend that much money. Okay, so now we have a new problem. This is the stopping distance of regular tires on glare ice. I don't really know what glare ice is, but it's with ice. That's kind of important. As a function of the air temperature. Okay, so depending on the air temperature will depend on stopping distance. D of F is the stopping distance in feet. Okay, so like when the temperature is 0 degrees, the stopping distance is, 2 times 0 plus 115. It's 115 feet when the air temperature is 0 degrees. And then I can do the same thing with this one. It's 2 times negative 20 plus 115. So 115 minus 40 is 75 feet. So when it's colder, I don't slide as far. I don't take as long to stop. I don't really know. But then it would seem that as the warmer it gets, so 2 times 32 plus 115. So 64 plus 115 makes 179 feet. Now maybe it takes longer to stop there because there's more water, so more of it is liquid, and you all know that wet ice is slicker than dry ice-ish. So maybe that's why. I don't know. So what's a reasonable domain for this? What kinds of temperatures can the Fahrenheit be? All right, we're looking for the Fahrenheit, and we're talking about ice. So how cold might it get? Well, I don't know, glare ice, something really pretty cold, right? So maybe the domain could be, I don't know, negative what? What do you want to do? 30? I would take that. That seems reasonable. And what's the warmest it can be for ice? Oh, 32, right? That's after 32, it becomes water, so we don't have the ice anymore. So a reasonable domain could be something like this. And we include those numbers or not, doesn't matter. Something like that. But 32 is kind of important because after 32, it stops being ice, right? There's no more ice. All right, so here's the next one. We've got a contractor that's buying a new truck. So the new truck is $38,000. Purchased on January 1, it's expected to last 5 years, at which time the trade-in value will be $16,500. Okay, so at the beginning, so when after 0 years, we've got 38,000, right? And after 5 years, we've got 16,500, right? Okay, if the company figures the decline or depreciation value to be the same each year, let's write a function that represents the salvage after t years. Well, we know that v of 0 has to be 38,000, right? And we know v of 5 because after 5 years, it's supposed to be 16,500. So can we find, let's say, a slope? All right, let's try finding a slope. Slope is the change in y over the change in x. In our case, our y value is the value, right? V of t is the y value. So this is my money over here. And t, that's my time, that's going to be down here at the bottom. So I'm going to subtract my monies. So I'm going to subtract 38 and 1650, right? Or sorry, 16,500. And it has to be negative because it's depreciating. So I'm going to go ahead and subtract so that it's negative. So 16,500 minus 38,000 over my time is 5 years. I could do 5 minus 0, but that seems kind of silly. So 16,500 minus 38,123,000, I'm typing it in my calculator, is negative 21,500 divided by 5 is 4,300, negative 4,300. What does that mean? That means it loses $4,300 every year. So if I put something here on my graph, let's say that I don't really know, 38,000. Maybe up here I've got 38,000. Okay, now this is kind of cheating on my graph, so don't get mad at me. So every year it goes down by 4,300. So let's say I subtract 4,300, 38,000 minus 4,300 is 3,370. So this is going to go down to 3,370 after 1 year. I'm going to go ahead and put 1 year there. So it starts here, then it goes here, then it goes down another, so minus 4,300. It goes down to 29,400. 29,400 it goes down to here after 2 years, and it goes down after 3 years, and it goes down after 4 years, and it goes down after 5 years. So by 5 years, this should be the number. What was the value? 16,500. 16,500. Okay, and so then I have this lovely line. The only thing I'm not exactly sure about, y'all, is I didn't count any of those boxes on the vertical. It's probably not right. Okay, so maybe I would put in the little squiggly thing like you do in science class to show that it's not exactly one-to-one relationship. Okay, so there you go. So the question, so what's V of 3? Oh, so do we have a slope? Yes, we have a slope of negative 4,300. And we have a y-intercept, right? Don't we have B? Yeah, that's the initial value, right? 38,000. After that, it's just going to go downhill. So 38,000. So you can write an equation, y equals mx plus b, or v of t is equal to negative 4,300 t plus 38,000. Once I know that, then I can figure the value after 3 years. Or I could have used my graph, right? I could have just kept subtracting. I've got it in my calculator. I could just subtract another one, right? So $25,100 if I did that. Or I can use my equation. All right, so that's V of 3. What are the domain and range, do you think? What do you think the range is? That's the y value, right? The range is the y value. So what's the highest y value we have? Right, 38,000. So that's going to be my top end of my range is 38,000. What's going to be the lowest most of my range? What's the lowest? Remember, this is the value of a truck. So the lowest would probably be, right, 0, because I can't get any lower than 0. That would be my range. What's my domain? Well, I guess my starting point would be 0, correct? And then after however many years that it is 0, I don't even know. I could figure it out, though, by putting my value here. Let me change colors real quick. I could put the value as 0 and try to figure out how many years it would take to get to 0, right? That's kind of cool. Lots of things you can figure out from this. So I'll add the 4,300 to both sides is 38,000. So I could take 38,000 divided by 4,300, and that gives me 8.8 years. So after 8.8 years, my truck is worthless. So maybe I put 8.8 here because that's when my truck becomes worthless. Something like that. You can't put infinity because eventually it's going to get to 0. So something like that would be great. Okay, so here's one. In a linear model, that's a line. Look, they gave us the equation where y represents the money in your pocket in dollars, and x represents the number of days since you got paid. Okay, so find the slope and interpret its meaning. Find the y-intercept. What does it mean? What the x-intercept, and what does it mean? And then graph it by finding the x and y-intercepts. Well, what does the slope mean, do you think? Now this represents, remember, the y represents money. So the y represents money, and the x represents days, right? And it looks like I have a negative slope, right? I got the slope. Slope is negative 20, and that's dollars. Let me write it differently. Negative, I don't even know where the dollar sign should be when I have a negative. Anyway, so I have negative $20 for each day. What does that mean? I think that means that I spend $20 every day, right? Money in my pocket goes down, so I think I spend $20 every day. I don't spend $20, but somebody does, right? The y-intercept, that's my b, right? 230. So what do you think that is? Well, I think it's the amount of money I get paid every payday. So I think 230 is the amount of money that I get paid. Because remember, each day since I get paid. So I think $230 is how much I get paid. I don't know if it's weekly or monthly or whatever. Obviously not daily, because subtract away. Now, what's the x-intercept? Remember, the x-intercept would be when y is 0, minus 20x plus 230. So 20x equals 230. 230 divided by 20 is 11.5. So that means after 11.5 days, I got no money. So if I were going to graph it, maybe I could put my graph here. This is 11.5. I got no money. To start with, I have $230, right? 230 here. And I'm not even really using the boxes, and then I'll graph it like this. It has a negative slope. So that's how I graph it. 11.5 days. And this is $230. All right, well, good luck.